Welcome to this screencast on the array list. It's the array-based implementation of the list interface we talked about previously. Here's our list interface. Remember, lists have a concept of an index. The things in the list have a position. They're indexed, so we can get the thing at an index. We can set the thing as an index. We can find the index of it. Lists are grow and shrink, so we can ask how big it is, how many items are in it. We can add to it at the end, or we can add to it in the middle, and we can remove things from it, so we can shrink the list. So this implementation of a list is going to use an array to store the data. So we have an array that holds the data. What that provides is a very quick access, because we can say, what's the third item, what's the seventh item, and we can set, so the gets and sets are very quick with this implementation because we can directly access them. A side effect, though, is because Java arrays are fixed size, that when our list gets large enough, we're going to have to resize the array, which means copying all the data into a new array and then assigning it back to our member variable. Another thing is that when the array has to be larger or equal to the size of the list, so that means we are often going to have empty space in our array that's not being currently used. And lastly, when we insert or remove, since there are no gaps, we're going to have to shift items around. We're going to have to move them up or down in the array, which causes a little bit of performance issue when we do our insert, the add, index, and the remove. But generally a very nice data structure, generally quick, and very useful to use. So let's talk about the implementation. We have our private member variable data. We can call it anything we want, but data is a nice name. It's an array of e's. Again, it's a generic, so that's the type that will, when we instantiate our array list, we'll tell you what type it is. And we're going to keep track of the size, because we could count them every time if we wanted to, but it's much more efficient to just keep track of the size, so that when I ask how big the thing is, the operation's a big O of 1, because I just return the value. But that does mean that I got to keep track of, whenever I add something, I got to increment the size. Whenever I remove something, I got to decrement the size. So that's why we have a size. The constructor needs to initialize all the member variables. So we have to initialize the data array, and we have to initialize the size. So when we create a new array list, we need to initialize the data. And so in order to initialize the data, Java doesn't allow you to create an array of type E, because E is a generic. So what we have to do is we have to create an array of objects and then cast that array of objects into an array of type E. And as you recall, object is the base class of all Java classes, so that this cast is legal. So we can store any of the items in an array of objects. In this case, I said the initial size is 10. For the array, you could pick any value you want. Generally, you want it to be large. Picking a value of 1 means you're going to have to grow it immediately when you add something. So you want to have it be large. 10's a nice number. 100 might be a nice number, but it depends on what your array is going to be used. So 10's a nice number. And so we need to initialize the size. So when you create a new list, how many items are in the list? Well, the answer is there are none, because our array has a size of 10, but the number of items in our list is 0. So the size is 0, and the array is empty. So now let's talk about the first set of methods that we talked about and going through, is how we get and set the items in the list. So for example, I have a list here of size 2. It's got foo and bar in it, and I want to get something at the index. Well, I can't get something at 9 because the list doesn't have that many items, and I can't get something at a negative number, so I got to check to see that the user of my list gave me a good index. So I got to check the index, and if that succeeds, then I can return the item at that index because it's a valid index. So in order to check the index, we just wrap it if. So if the index is negative, that means it's not a good index. And if the index is greater than or equal to size, because we don't have anything at size, remember we start at 0, so size is not a valid index. It's one past our thing. So if it don't have a valid index, we throw an index out of bounds exception, indicating that the user gave us a bad index. If that passes, then we know we have a good index, and so we just return the data, the item at index, which would be just data sub index. So we return it. So now let's talk about the set. So very similarly, the idea is we need to check the index because we have an index. The set method returns the thing that was in the list. So we got to remember the old value, because once we overwrite the value, we've lost it. We then overwrite the value, and then we return the old value. So again, we check the index. Again, size is greater than or equal to size, because size is not a valid index. We throw our exception. If we don't throw an exception, then we want to remember the old value by just assigning a temporary variable, called it E or old or temp or whatever. We get the value at index. We then set entry to be there, so data index equals entry. And then we return the old value, which is just return old. And so now we have set the value of whatever it was to a new value. So what are the big O operations? Well, you can see the get, we don't have any looping, and we just do an if statement and then a return. So that's a big O of 1. It's all constant time. There's nothing based upon the number of items in the list, because we just go to that. The access of the array is big O of 1. Same thing with the set, is we have a check and then we're just constant time. So that's a big O of 1 also. So the array list implementation is a very efficient when you say, I want to get things out of it and replace things in it. So the next method is the index of. So we're looking for something in our list, and so we need to search through the list looking for O, which is the parameter we're passing in. If O is in the list, we return whatever index we found it at, and if it's not, we return -1, indicating that it's not in the list. So the first thing is we want to search through all the items in the list, so we just do a for loop from 0. And we don't need to go to the end of the array, we just need to go to size, because we know that's where all the things are in our list. So now we got to decide whether or not the item at I is what we're looking for. So we can say data sub I equals O, and I have a missing parenthesis. Then we return I, because we found the item, and we return the index of where that thing lives. If we get to the end of the for loop, we've looked at every single one of the items in our list, and it's not O, then we return the -1. So that indicates it wasn't in the list. So what's the big O performance of this? We have to go through potentially all the items in the list. So that's a big O of N operation. So finding the index of an item can be expensive. Returning the size, like I said earlier, we keep track of the size in order to make this a quick operation. Otherwise, we'd have to count the items. So since we're not going to count the items, we're going to just return the size and the big O of 1. So now we want to add something to our list, and we're going to, the add method that takes one parameter entry, type E, adds it to the end of the list. So we've got to make sure, because our array could be full. We could have data size items. So let's say in this example, if we had 10 items and we call add, what do? Well, we need to grow the array. So the first thing we need to do is check to see if it's full. If it's not full, then we continue on our merry way. If it is full, we have to grow the array by copying it from the current array into another copy that's larger than the current array. And then now we know we have room, so now we can go through and add the entry to the end of the list. Because we added something, we have to increment the size, and because add method has a Boolean that says whether or not we're successful, we were successful, so we return true. So to check to see if the data is full, we check to see if size is equal to data length. And if it is, we need to grow the data, which we can just say data equals array's copy of. An array's copy of is a very helpful method that takes an array and then it copies the contents of the given array to the result, the return value, and it will make it as large as the second parameter, which is saying we're going to double the size of our array. And we're going to copy the contents from data into this new array, which will copy the contents of data and then have a whole bunch of nulls after it. And then we assign that to data. So we're in effect doubling the length of the private member variable data, but we do have to copy the array. So we're actually creating a new array, copying the contents, and then returning it. So that's a very nice way of making the array larger. Why'd I pick ×2? I could have picked +1, but then if I add it again, I'd have to do a copy again. So nice compromise is just doubling the size of the array. Eventually, I may have a very large array, but I still won't grow it the next time. So once I know that I have room in my array, I can add the entry to the end of the list, which is just at size. So that's the next empty spot. So now it's full. So now I need to say I added something to my list, so I increment the size. And now that I can say I now have a size of 3, and then I can say I successfully added my entry. So what's the big O of this method? Well, every n times I have to copy n items, so that's a big O of n for the data array, but I only do that every nth time. So the effect is the add entry will be slow every nth time, but it's because you only do that big O of n once every nth time, so you divide big O of n, divide by n, which is a big O of 1, actually. So now the next method is we want to add an index, so we're going to insert something into our list. So again, because we have an index, we've got to check the index. Because we're adding, we got to check to see if the array is full. If the array is full, we're going to grow it just like we did for the add method. But the key is for this one, since we're sticking it in the middle, we have to shift the elements from index to size over 1 and then add the element to the list. We then can increment it, and then since it doesn't have a return type, we don't have to do anything with the return. So we check the index just like we can, and this time note that I can add at the end. So if I say add at size, that is legal because that's just what the add method does. So I can say greater than or equal to size, or greater than size, because if it is equal to size, that's legal. Throw my index out of bounds exception if it's not legal. I check the size by checking size versus data length. If it's full, I grow it by doing my array's copy of, and I double the length of my array. And then so now I got to shift the element. So for example, if I'm going to insert at 1, the thing foobar, I'm going to go from 1 to size. My size is wrong, it's 3, but I go to size. So I shift my element, so I go to a for loop, and I'm going to start at size, and I'll go to index, because if I start at index, I'll copy over the thing that I need to create the gap. So you can see I moved the thing from 2 to 3, creating a gap, because I started at size, and then I'm going to do the next one. So now I've created a gap, so I'm done. Index was 1, so now I can add the entry to the list, which is just data index equals entry. And then remember, because I've added 1, I got to increment my size. So there it is. What's the big O of this? Again, we have the big O of n for the looping, and unfortunately, we do this every time we do an added index. So this operation is a big O of n. So it's not in the array copy, it's a big O of n, but that only occurs once every n times. So that's still big O of 1, but this shifting of all the entries is a big O of n. So the add at index is a big O of n operation. Now we remove, same thing, because we have an index, we got to check it. We then remember, because we returned the thing that we removed, so we got to remember it, because if we just shift the things, we'll forget it. We then have to shift it because we don't have any gaps, and then we decrement the size because we've removed it, and then we return the removed value. So again, we check the size, and again, here, size is not a valid index, so we got to use the greater than or equal to size. We want to remember the value that we're removing. So we set up a temporary variable, could have called it old, could have called it temp, called it return value. We then shift them, and now instead of shifting from the size end, I'm going to shift from index. And so I'm going to go from index +1 to size, and I shift them over. So the first one, I'm going to move from I to I-1, which would be index to +1 to index. And then the next one, so now I have shifted all the items, and there's no gap in my list. I can decrement the size to make it 3, and then I return the return value, the old value that was in the list and is no longer in the list. And then what's the big O? Again, the shifting of the values is giving us a big O of n. So there you have the array implementation of the list, and you can see that it's fairly simple, straightforward implementation. We just have to sort of check the indexes when we need to. When we add things, we got to check to see that our array isn't full, because if it is full, we need to grow the array. And then we got to remember to make sure that when we add things, we increment the size, and when we remove things, we decrement the size, because we want to just quickly, if they ask how big our array is, we don't want to count every item. We just want to return the size immediately. Thank you very much.